This is Professor Kitch, and welcome to this webcast where I'll be going through examples of using the USCS to classify coarse grain soils. I'll be classifying 6 different soils in this webcast. The grain size distribution for the first 3 soils, A through C, are shown here. Let's start with soil A. Recall our first question is whether this soil is a sand or a gravel. In this case, we can see that the entire grain size curve lies within the range of sand-sized particles, so this is all sand. Next, we need to look at the percent fines. In this case, we are well less than 5% passing the number 200 sieve. So our next question is whether or not the soil is well graded. First, we'll check the coefficient of uniformity, Cu, which is D60 divided by D10. For this soil, D60 is 0.35 millimeters, and D10 is 0.25 millimeters. This gives us a Cu of 0.35 divided by 0.25, which is equal to 1.4. This is less than the value of 6 required for sands to be well graded, so this is a poorly graded sand, and there's no need to check the coefficient of concavity, C sub C. The symbol for this soil is SP. We can skip step 4 since this is a clean sand with very few fines. Our last step is to check the percent gravel, which is 0 and therefore less than 15%. So, our final classification of this soil is SP, poorly graded sand. Notice that we were able to skip a number of the steps in this classification process. Next, we'll look at soil B. Our first step is to determine if there's more gravel or more sand. We see that 92% of the soil passes the number 4 sieve, so the percent gravel is 100 minus 92, or 8%. The percent finer than the number 200 sieve is 4%. So the percent sand is 92 minus 4, or 88%. So the soil is a sand, which was already obvious from the grain size distribution curve. Question 2 is about the percent fines. In this case, there are 4% fines, which is less than 5%, so this is a clean sand. Now we need to determine if it's well graded. D60 is 1 millimeter, and D10 is 0.16 millimeters. So the coefficient of uniformity is 1 divided by 0.16, which equals 6.25. So this soil passes the first check since C sub U is greater than 6. Now we need to check the coefficient of concavity. C sub C is D30 squared divided by D10 times D60. D30 for this soil is 0.5 millimeters, and C sub C is 0.5 squared divided by the quantity 0.16 times 1, which is equal to 1.56. This is in the range of 1 to 3, so this soil is well graded and its 2-letter designation is SW. We can skip step 4 because the fines are less than 5%. Our final step is to check the percent gravel, which is less than 15%. So our final classification for the soil is SW, well graded sand. Our last soil in this group is soil C. First, we need to compare the amount of sand with the amount of gravel. 48% of the soil is finer than the number 4 sieve, so the percent gravel is 100 minus 48, or 52%. 2% of the soil passes the number 200 sieve, so the percent sand is 46. Now there's more gravel than sand, so this soil is a gravel. There are 2% fines, so this is a clean gravel. Now we need to check to see if it's well graded. D60 is 20.5 millimeters, and D1 is 0.2 millimeters. So the coefficient of uniformity is 20.5 divided by 0.2, which equals 102. 102 is much greater than 4, so now we need to check the coefficient of concavity. D30 is 0.61 millimeters. So C sub C is 0.61 squared divided by the quantity 20.5 times 0.2, which is equal to 0.09. 0.09 is well less than 1. Therefore, this soil is poorly graded, and its symbol is GP. We don't need to check the fines since they're less than 5% of the soil. And our final check is the percent sand, which is well over 15%. Therefore, the final classification of this soil is GP, poorly graded gravel with sand. Okay, so much for the easy soils. Let's classify some more difficult soils. Next, we'll classify these three soils, which are coarse-grained soils, but each with a significant amount of fines. Let's start with soil D. First, we'll determine if it's a sand or a gravel. We look at the top of the graph and see there's 0% gravel. The percent passing the number 200 sieve is 28, so the percent sand is 100 minus 28, which is 72%. So this is a sand. Checking the percent fines, we know they are 28%. So this sand has well more than 12% fines, and it must classify as either SM or SC. We don't need to check the gradation since the fines content is over 12%. So we can move on to checking the type of fines. To do that, we'll need to know the liquid limit and the plasticity index of the fine part of the soil. From our Atterberg limits test, we find that the liquid limit is 45 and the plastic limit is 32. This gives us a plasticity index of 45 minus 32, which is 13. We'll need the Casa Grande chart to classify the soils. And there we'll plot a point with a liquid limit equal to 45 and a PI equal to 13. This point plots below the A line, and the fine material classifies as ML, silt. So the group symbol for this soil is SM. The last step is to check the percent gravel, which is less than 15, and the soil classifies as SM, silty sand. Notice that we were able to skip the gradation check because of the large amount of fine material in this soil. Next, let's classify soil E. First, checking the percent gravel and the percent sand. 88% passes the number 4 sieve. So the percent gravel is 100 minus 88, or 12%. 10% passes the number 200 sieve. So the percent sand is 88 minus 10, or 78%, and the soil is sand. Checking the percent fines, we find it's between 5 and 12%. Therefore, this soil will have a dual classification. We'll have to check the gradation starting with the coefficient of uniformity. D60 is 1.5, and D10 is 0.075. C sub U is 1.5 divided by 0.075, which equals 20. This is greater than 6, so we pass the first check for a well-graded, and we need to check the coefficient of concavity. D30 is 0.3, and C sub C is 0.3 squared divided by 1.5 times 0.075, which is 0.8. 0.8 is less than 1, so this soil is poorly graded. And the first symbol in this dual classification is SP. Now we need to check the fine material. So we do our Atterberg limits test and find that the liquid limit is 63 and the plastic limit is 22, which gives us a plasticity index of 63 minus 22, or 41. Using the Casa Grande chart, we plot the point and find that it falls above the A line, and the fines classify as CH. So the second symbol for this soil is SC. Our final check is the percent gravel, which is less than 15%. So the final classification of this soil is SPSC, poorly graded sand with clay. Notice that we had to check both gradation and the type of fines for this soil because the percent fines was between 5 and 12%, and the soil has a dual classification. Our final soil is F. Again, we start with the determination of the amount of sand and gravel. And we find that the percent passing the number 4 sieve is 57%. So the percent of gravel is 100 minus 57, or 43%. The percent passing the number 200 sieve is 18%. The percent sand is 57 minus 18, or 39%. So the soil is a gravel. Notice that less than half of the soil is gravel, but it still classifies as gravel because the percent gravel exceeds the percent sand. Now we check the percent fines and find that they're greater than 12%. Therefore, the soil must be either SM or SC, and we don't need to check the gradation of the soil. We do need to check the fines. So we perform Atterberg limits test on the fines and find they have a liquid limit of 41 and a plastic limit of 37. This gives us a PI of 41 minus 37, or 4. Using the Casa Grande chart, we plot the point and find that it classifies as ML. So the soil group symbol for this soil is GM. We do our final check on the percent sand and find that it's much greater than 15%. So the final classification of this soil is GM, silty gravel with sand. The tricky part of classifying this soil is to realize that it's a gravel even though less than 50% of the soil is gravel. Remember, when determining whether a coarse grained soil is a sand or a gravel, the question is whether there's more gravel or sand in the coarse grained fraction of the soil, not whether more than half of the total amount of soil is sand or gravel. Well, that's the end of this set of example problems for classifying coarse grained soils. I think I've taken you through almost all the nuances of classifying coarse grained soils using ASTM D2487 and the Unified Soil Classification System. Here are some key things to remember. First, follow the chart. Second, check the percent fines first. This will tell you if you can skip part of the flow chart. If the percent fines is less than 5%, you only need to do the grain size analysis. You can skip checking the Atterberg limits. If the percent fines is greater than 12%, you only need to check the Atterberg limits, and you can skip checking to see if the soil is well graded or poorly graded. If the percent fines is in between, you're out of luck and you'll have to check everything. When determining if the soil is gravel or sand, remember that it's based on which is the greater percent of the coarse grain portion of the soil. It's not based on the percent of the total sample. Well, that pretty much wraps it up. I hope you found these example problems helpful.